Hi, my name is Niroshini Suresh, and I'm a final year student studying Bachelor of Civil Engineering Honours, Diploma in Professional Engineering Practice. Today I will be delivering my Capstone project through the investigation on finding a cost-effective method for harvesting fresh and marine microalgae biomass. This investigation was conducted over the last 10 weeks at the Center for Technology in Water and Wastewater, under the supervision of Dr. Luang Yuan. This topic I've chosen is fairly new to me when I started, as this is more based on environmental engineering, and thought why not enhance my knowledge in other fields too. Reflecting on my journey so far, I feel satisfied and accomplished to have developed a greater understanding on harvesting microalgae, and I am excited to talk you through my project. Did you know microalgae has been used for human consumption such as food? Microalgae have recently attracted attention worldwide due to their widespread application in their food ingredients. Nowadays, they have been used in a variety of vitamin supplements, protein bars, powders, green smoothies, omega-3 capsules, and many more. But there is more to it. Microalgae are microscopic algae, typically found in freshwater and marine systems. They can perform photosynthesis, meaning that they utilize sunlight, carbon dioxide, and nutrients to grow. Thus, microalgae can be cultured in non-arable land, while capturing global warming gas carbon dioxide. For example, Arava Desert is well known for the cultivation for microalgae due to the high intensity level of sunlight produced throughout the year. Microalgae can produce approximately half of the atmospheric oxygen. So every breath that you and I continuously have, half of it is thanks to microalgae. These microscopic organisms and their products are used for different purposes like energy, pharmaceuticals, human food, animal feed, agriculture, and cosmetics. For the last 2 decades, microalgae started to take a new development with expanding applications aiming for the depletion of fossil fuel reserves, the resulting increase of oil prices, and global warming concerns. However, to obtain the benefits of microalgae, we must cultivate, harvest, and process the algae biomass. The harvesting is an integral process and has been the bottleneck of the whole system, where processes of centrifugation, electrolysis, and filtration are costly and have high energy and time consumption. Especially when harvesting small cell sizes of microalgae suspensions, they usually have a concentration of less than 1 gram per liter, which requires high intense production to get these biomasses from their algae culture. To put in a perspective, harvesting 1 gram per liter of microalgal biomass is more difficult to remove 3 sand particles out of 1 liter. Therefore, the urge to implement a new harvesting solution is needed in reducing environmental and economical impacts. The research team has come up with a solution in harvesting microalgae called flocculation, a cost-effective and energy-efficient technique using different flocculants to perform the task. It is a concept of aggregation where many small particles form a small number of large flocks. The coagulation process is small particles carry negative surface charges where the flocculant absorbs the particles and balances the charges. The aspect of opposite charges enables particles to stick together to form stable and well-suspended flocks. As illustrated in the images, our effective flocculant was inserted into the microalgae culture, forming the separation of flux and the clear water. A sieve is then used to remove the algae biomass from the clear water, which is then ready for commercial users. According to our research solution, our flocculants have over 95% of efficiency in comparison to centrifugation, filtration, and other methods in terms of operational cost, energy demand, and time consumption. Thus, our solution is effective as it overcomes the issues in harvesting microalgae. Harvesting large biomass is easy. However, cultivating low concentrated algae or small suspension cells requires high production. Our flocculant is capable to harvest low concentrated cells, which helps the market growth as more products or processes can be produced whilst being sustainable and economically feasible. Therefore, our process will be competitive in the market as our solution overcomes the challenges and able to increase the market whilst increasing awareness among consumers about health benefits of microalgae products. At my current stage, I'll be working towards whether our flocculant will work with all types of microalgae species, and to investigate upon its reaction on how much flocks are formed when using our flocculant. Further, a research will be conducted to understand different algae's properties and characteristics to find more flocculants that can work well with other algae cultures, whilst collecting information as to why such algae reacts more compared to others. Thus, it is believable to say microalgae will be the future bioeconomy.